Today we start about one important topics of calculus, the chain rule for derivative. Okay, also start today. Let U be an open set of Rn and if U to Rm be a function such that f is differentiable at point C, f is differentiable at point C, at point C belongs to U, and let G fu to Rp, okay, be a function such that such that G is differentiable at point Fc. G is differentiable at point Fc. Then define f equal to G naught f. Then f is differentiable at C. Then f is differentiable at point C. Differentiable at point C. And f test C equal to G naught f test C. Okay, that means G dash of fc, here f test C. Okay, we also discuss this chain rule. Proof of this chain rule first. We write proof here. Then set b equal to fc and capital A equal to f test C and capital V equal to G test fc and equal to G test B. Okay, then we'll start about that. Since f is differentiable at C, f is differentiable at C, then there exists a function, R1 R to the power n to R to the power m with domain neighborhood 0 such that with domain neighborhood of 0 or neighborhood of domain here neighborhood of 0, R1 with domain neighborhood of 0 such that here f of C plus h equal to f of C plus AH plus R1H. Okay, then R1 equal to, then with norm of R1H divided by norm of H tends to 0 as H tends to 0. Then what happened? Then we just write definition of f differentiable. Now we're going to set since fc equal to b, since fc equal to b, then f of c plus h equal to b plus k. Okay, for some b belongs to r to the power n and k belongs to r to the power m. Okay, since c is differentiable at b, we erase this portion. Since g is differentiable at b, since g is differentiable at b, then there exists r2, then there exists r2 such that r to the power m to r to the power p with domain neighborhood of 0, with domain neighborhood of 0. Okay, then with domain neighborhood of 0 such that g of b plus k equal to g of b plus bk plus r2k with norm of r2k divided by norm of k tends to 0 as k tends to 0. Okay, now k equal to now k equal to f of c plus h difference f of c. Okay, since f is continuous at c, since f is continuous at c, it follows that k tending to 0 as h tending to 0. Note that VA belongs to L of r to the power n r to the power p. Okay, now f of c plus h difference f of c difference BAH equal to g of fc plus h difference g of fc difference b of ah equal to g of b plus k, here g of b, here b of ah. This one equal to capital B k plus r2k difference b of ah. Okay, this equal to p of k difference ah plus r2k. Okay, now we put this value of k, we get put the value of k, we get this equal to b multiplied of f of c plus h difference f of c difference a plus r2k. Okay, then this one equal to b of r1h plus r2k. This Now, we erase that portion and going to further discussion about that. Now, for age belongs to Rn, for age belongs to Rn, each age not equal to 0, each age not equal to 0, we get norm of f of c plus h, difference f of c, difference BAH less than equal to norm of h. This less than equal to 1 by norm of h. Here B norm of B R1H plus norm of R2K. Okay, this equal to 1 by norm of H. Here norm of B, norm of R1H plus norm of R2K divided by norm of K multiplied by norm of K. Okay, then this equal to norm of B, norm of R1H by norm of H plus norm of K multiplied by norm of R2K divided by norm of K. This tends to 0. Here sorry, this one is here norm of H. Then this one tends to 0 as H tends to 0. Okay, then we write about that this one if is differentiable at C, if is differentiable at C, and if dash C is equal to VAH. Okay, now BA equal to G dash FC, here F dash C H. So F dash equal to this one. So F dash C equal to G dash FC multiplied by F dash C. Okay, so we also prove this chain rule. Now we also give example of this chain rule. Okay, example of this chain rule. We erase that portion and going to further discussion about that. Now we write here example. Okay, let F R square to R square and C R square to R cube then G naught F equal to R square to R cube. Okay, now we write here f of xy equal to x square y square here x square difference y square difference 3x 3xy and gxy equal to x square y cube xy x to the power 4 y to the power 4. Okay, then we also talk about here if dash ab equal to if dash ab equal to here we write 2ab square 2 square b and here 2a 3b difference 3b here 2b difference 3a. Okay, now here g dash alpha beta equal to okay here 2a b cube here 2 3 a square b square here 0 sorry this one is not just 2. Okay, then here b here a here 4 a cube here 4 b cube. Okay, then we're going to further discussion about that. Oh sorry, here we construct alpha beta, then this one alpha, this one beta. We erase this and again write here. Okay, because this one 2 alpha beta cube here 3 alpha square beta square, then here beta here alpha here 4 alpha cube here 4 beta cube. Okay, then we write now g dash of a square b square g dash of a square b square and a square minus b square minus 3ab equal to how much? G dash of this equal to right here 2 a square b square a square minus b square minus 3ab whole cube. Okay, here 3 multiplied by a to the power 4 b to the power 4 a square minus b square minus 3ab whole square. Now beta equal to a square minus b square minus 3ab, alpha equal to a square b square, 4 alpha cube equal to a square b square whole cube, and 4 beta cube equal to a square minus b square minus 3ab whole cube. Okay, then we're going to result of f dash ab equal to g dash of f ab here multiplied by okay multiplied by f dash ab, then this one multiplied by this one, and we're going to be then means required result. We also know matrix multiplication, then we do it and we also getting result. Okay, So we erase this portion and then going to discussion about we know about this matrix multiplication, so we not do here, we just write this two. Okay, here we write this two, this one 2a square b square a square minus b square minus 3ab whole cube. Here 3 a to the power 4 b to the power 4 a square minus b square minus 3ab whole square. Okay, here a square minus b square minus 3ab. Here a square b square. Here 4 a to the power 6 b to the power 6, and here 4 a square minus b square minus 3ab whole cube. This multiplied by this one 3 cross 2 and 2ab square 2a square b 2a minus 3b, here minus 2b minus 3a, here 2 cross 2. Okay, then we erase this portion and going to further discussion of another. Okay, we erase here and going to further discussion of that. Now we write here if r to r square f of xy equal to, or f of x equal to x plus y, here xy, for x y belongs to r, then g r square to r cube, g of xy equal to x square y square, here x square plus y square, here x cube y cube. Okay, for all xy belongs to r square. Then define f to r cube fx equal to g naught fx for all x belongs to r. Okay, then how we do it? First we write f test c equal to here we write just 1 and here just c. Okay, sorry, just y here. Okay. Then g dash of alpha beta equal to 2 alpha beta square and 2 alpha square beta, here 2 alpha 2 beta, here 3 alpha square beta cube and 3 alpha cube beta square. Okay, then we write here g dest of c plus y cy equal to g dash of c plus y cy equal to how much? Here we write 2 c plus y and c square y square and 2 c plus y whole square cy. Okay, here 2 c plus y, here 2 cy, then here 3 c plus y whole square cy whole cube and 3 c plus y whole cube and cy whole square. then obviously we write here now g dash cy multiplied by f dash c equal to this one 2 c plus y c square y square and 2 c plus y whole square cy by 2 c plus y 2 cy here 3 c plus y whole square cy whole cube 3 c plus y whole cube cy whole square multiplied by 1y. So we also know about matrix multiplication, so we do it, I think. Okay, then we also proceed this rule, that means just f dash c equal to g dash f c multiplied by f dash c. Okay, now we're going to discuss about one simple topic. Okay, one simple topic. This one is norm of f. We write this one now. Okay, then today we stop. Let R an inner product be an inner product space. Be an inner product space. And let if R into R be a linear operator. Be a linear operator. Then f is bounded. Then f is bounded. Okay, let L R into R. Okay, let L R into R in R be the collection of all linear operator from all linear operator from Rn to R. So for f belongs to L Rn R, norm of f equal to supremum of x belongs to Rn and x not equal to 0, mod of fx by norm of x. Okay, then this one equal to norm of f. Then today we stop here. Okay, today we